Lesson 4.8, mixed multi-step factoring. So this is really the end goal, is throwing any kind of problem at you and you identifying, how do I factor it? And over here on the left are the different categories. So this will take a little bit of time, but it's going to go through everything that you might see. And my biggest advice to you, always, always, always check for a greatest common factor first before you do anything else. So 1 and 2 happen to be just GCF onlys, but let's just pretend we had no idea what we're doing. I would look and say, okay, this is a 5 and this is a 45, so I could factor out a 5. They both have r's, so the most I could take would be the r squared. Then you just write what's left over. So 5r squared times what would make 5r to the 5th? That would be r cubed. 5 times 9 make 45, and I don't need any other r's. So just make sure that this can't go any further, and it can't. So I would stop there. All right, number 2, I see -2 and -56. I'm going to factor out a -2, and then I see s's. I would take out an s cubed. So I don't need to multiply by any other number. It's already -2, but I would need s to the 3rd power to make that s to the 6th. Plus 56 divided by 2 would be 28. I don't need any more s's, and that can't go any further. So those are the simplest ones. And then we saw these before, but let's talk about them again. Difference of squares. That's where you have two things, two terms, subtraction between them, and they're both perfect squares. Whether it's numbers, whether it's exponents being an even number, that's what that is. And when you factor them, it's really easy. They're exactly the same, except for one's a plus, one's a minus. And so in this problem, check for a GCF. I can't take out anything from 4 and 25, but they do have c's. So I'll take out a c cubed. That'll leave me with 4 c squared minus 25. So I'm done with that part. Now look at this. See how there's subtraction? 4 is a perfect square, 25 is a perfect square, 2 is a perfect square because it's even. So I'm going to make 2 sets of parentheses. Square root of 4 would be a 2. Split the c squared, so you're really just dividing by 2, so c times c. Square root of 25 is 5 times 5. One's a plus, one's a minus. And the reason that it's different signs is so that we can multiply and get the 4c squared, get exactly the same terms on the inside, outers and inners, so we get a negative 10c and a positive 10c. Those would cancel. 5 times -5 makes -25. And then bring down my c cubed. That would be my answer. All right, number 4. We're leading with a negative, so I want to take that out. I can also take a 2 and a c. And so that will leave me with c squared minus 4. Right? Okay, I'm done with this part, but now here's a c squared and a minus, and that's a perfect square. So I would make 2 sets of parentheses. What times itself made c squared? C times c. What's the square root of 4? 2, 2. One's a plus, one's a minus. And drop down your negative 2c. Right, sometimes you have difference of squares twice. Let's try one of this. So I would take out an m squared from both terms. That leaves me with m to the 4th minus 1. So this is still an even power. That means I can split it up. So that would be an m squared times an m squared. Square root of 1 is still 1, so it'd be plus 1 minus 1. Which one can I do again? The one that has subtraction. It doesn't work with addition. And so all I would need to do is take this one more step further to say, splitting up the m squared would be m times m. Square root of 1 is still 1, so one's plus 1, one's minus 1. And then bring down the other stuff too. So it has 1, 2, 3, 4 factors. And if at any point in time you want to pause and try the even one, that's fine. Okay, the next one I would take out a negative, a 5, and a c squared. So that would leave me with c to the 4th minus 1. This one is very similar to what we just did. I would do this again. And then I would do the one with subtraction again. And it doesn't matter which order you do, if it's C plus 1 or C minus 1 first. Just make sure everything is factored. Okay, then we have basic trinomials. Remember, basic is when the a value is just a 1. And you might be saying, well, it's not here. It can be, because I can take out a 4 from all three numbers, and I'm going to take out a negative. So I'll take out a negative 4. Can't take out a u, so that would be u squared minus 9u minus 10. And then I would just need to factor this part again. Need two numbers that multiply to make negative 10, that add to make negative 9 would be negative 10 and positive 1. I see nothing else squared, so there's nothing else that could be factored. Number 8, this leading coefficient is a 1, but I also see where I could take out a u squared from everything. Then I need to factor this part again. Easy enough. I need two numbers that multiply to make 4 and add to make 4. 2 and 2. So you could write like this, or you could write u plus 2, that amount, that quantity squared. Either answer is fine. Okay, turn it over to the next page. Now we have slide and divide trinomials. That's where your a value is bigger than 1, or just anything other than 1. Looks like I could take out a 2, a negative 2 from each number. So that would be 5h squared. 8 divided by 2 would be 41. And then negative 16 divided by negative 2 would be positive 8. Okay. So now I need to take the 5, slide it to the 8, h squared minus 41h plus 40. Factor like normal. I need two negatives, so it would be negative 40 and negative 1, but go back and divide by 5. 40 divided by 5 would be 8. This doesn't divide, so I slide the 5 up. That would be 5h minus 1. Don't forget about the negative 2 from the very get-go. Okay, so think about if you FOIL, this would get 5h squared. Taking that times negative 2 gets the negative 10h squared, so you can kind of see where that's leading. All right, number 10. I can factor out a 5q squared. And that would be times a 5q squared minus 7q plus 2. See how this a is a number, so I'm going to have to do slide and divide. 2 times 5 is 10. Factor like normal. I need two negatives again. That would be negative 5 and negative 2. Go back and divide by 5. So that divides to make negative 1. That slides up to make 5q minus 2. Bring down the 5q squared. Three more. Factor by grouping. Remember, that's grouping the first two terms and the second two terms and then rewriting it somehow. First thing I would want to do is take out a negative and a z cubed. And so taking out a negative will actually change all of these now to positive inside here. So it would be z to the third plus 2z squared plus 16z plus 32. Okay, now focusing just on this, I'm going to look at a GCF here. I can take out a z squared, and that would leave me with a z plus 2. Bring down your middle sign, take out a 16. That would leave me with a z plus 2. Remember we said these have to match. How you write your answer is taking z squared plus 16 and putting it together. And then your z plus 2 and putting it together. So that was just factoring this, but don't forget to bring down your GCF from the beginning, which was negative z cubed. Number 12. Oh, I shouldn't do that yet. I see we're leading with a negative, and we can take out, looks like a 2 from everything. Everything's even. Yep. So that would leave me with 3a cubed minus 5a squared plus 12a. And then 40 divided by negative 2 would be negative 20. Okay, now group. Take out an a squared to have 3a minus 5. Bring down your plus. Take out a 4 to have 3a minus 5. So we did it right. We got a squared plus 4 gets put together, times 3a minus 5 gets put together, and then bring down my negative 2. I can't factor that anymore because that's not minus 4. One more. Factor by grouping and then difference of squares. Okay, can we take anything out? Not a number, not an s, but a negative. So let's do that first. Changes that. Changes. Group, because there's 4 terms. I can take out an s squared. Bring down my minus, take out a 9. Okay, rewrite it. So it's s squared minus 9 times s minus 3. Bring down my negative. See how I have a difference of squares right here? Because this is s squared and then it's minus and 9 is a perfect square. So we need to do that again. Split that s squared up into s times s. Square root of 9 would be 3 times 3. 1's a plus, 1's a minus. You could write like that, or you could write like this, where s minus 3 is happening twice. Either one is fine. And that's it.